Okay, so pressing on in our study of chemistry, we want to look at properties and changes of matter. So first of all, physical and then chemical. Well, first of all, really, changes. Physical changes. Changes that are physical are changes that alter state or appearance. Chemical changes are changes that alter composition, and sometimes they also alter state or appearance. Some examples then are water boiling. This is a physical change because we are changing its state or appearance but not its composition. Right? So you have water molecules here as a gas, water molecules as a liquid. When they go from a liquid to a gas, they change its state or appearance. It goes from a liquid to a gas, changing its state, but not its composition. It's still H2O. Okay, another example would be iron atoms. So if you look at this, let's suppose this nail is made up of iron, okay? And in the iron atoms, in iron, the iron atoms are arranged in a very ordered fashion. By the way, is this a crystalline state, or amorphous? Going back a couple sections. All right, so you have these iron atoms which are arranged in a pattern. When it's oxidized, you have oxygen atoms which are intercalated in there, and it becomes iron oxide. Can you see that the composition is being changed? Therefore, this is a chemical change. Okay, another physical change is dry ice subliming, when you go from a solid to a gas. So, when carbon dioxide presents as a solid, it's called dry ice. And it turns out you've got these carbon dioxide molecules which are all ordered in an ordered fashion as a solid. When it evaporates, or not evaporates, sorry, when it sublimes, it goes to a gas. Okay, this is called sublimation. Well, the composition is not changing, right? It's only the state. And so this is a physical change. All right, what about sugar dissolving? What about sugar dissolving? When sugar dissolves, you have ordered array of sugar molecules, C12H22O11. That's really sucrose. All right, so you have the solid, and then it gets dissolved in water, right? So here's these water molecules which are surrounding the molecule of sugar, and so we say that it goes from solid to aqueous. So it's changing its state, but not its composition. Its actual composition, that is, it's all still sugar. Can you see that? There's a sugar molecule, here's a sugar molecule. That makes this a physical change. All right. What about propane gas burning? So here's like you've got a little camping stove, propane stove, and you have propane in there, and it's combining with oxygen to make carbon dioxide and water. Right? Can you see that here's your propane molecules? Not shown is the oxygen in here, but the propane, which is a bunch of carbons and hydrogens. The carbon comes from here and goes into a carbon dioxide molecule, and the hydrogens, which are here, come off and go into water molecules to make carbon dioxide and water. So this is definitely changing its composition. All right, so this is a chemical change. All right, so let's look at physical properties then, and chemical properties. Physical properties are odor, taste, color, appearance, melting point, boiling point, density, and such. Chemical properties are things like corrosiveness, flammability, acidity, and toxicity. Essentially reactivities, right? Chemical reactions, reactivity. So these are physical and chemical properties, and let's move on to an example then. Physical and chemical changes and properties. So this is in your textbook in page 10. is each change physical or chemical? Which kind of property, chemical or physical, is demonstrated in each case? All right, so first of all, A, the evaporation of rubbing alcohol. Is that physical or chemical? Okay, so if you said physical, you're right. It's a physical change. And what property is it demonstrating? It's demonstrating the vaporization or the evaporation of rubbing alcohol. So really, essentially the boiling point of rubbing alcohol. Just a second here. Okay, when rubbing alcohol evaporates, it changes from liquid to gas, changes its state, but it remains alcohol. So it's a physical change. The volatility or its vaporization of alcohol is a physical property. Okay, what about the burning of lamp oil? So we've talked about burning in a couple examples. The burning of lamp oil, that would be the oil combined with air, oxygen, to make carbon dioxide and water. That's definitely a chemical change. So what property is demonstrated in this case? It's flammability, right? What? Okay, just a second, there we go. Lamp oil burns because it reacts with oxygen and air to form carbon dioxide and water. This is a chemical change. Flammability is the property that's demonstrated. What about the bleaching of hair with hydrogen peroxide? Well, that's definitely a chemical reaction, right? So it's a chemical change, and the property is the reactivity of hair with hydrogen peroxide. It's a reactivity, or its bleachability. Just a second here. Okay, applying hydrogen peroxide in hair changes pigment molecules in hair that give it color. There's a chemical change. Susceptibility of hair to bleaching. Okay, good. What about the forming of frost on a cold night? All right, the forming of frost is essentially water coming out of the air and making ice. So that's the same as boiling point, but the opposite. It's the opposite of boiling point. That's its fusion. Just a second. What's going on here? Frost forms on a cold night because water vapor and air changes its state to form solid ice. Physical change. Temperature, so it's freezing point. It's the same as melting point, but the opposite direction. Okay. All right, I hope that's helpful. At the end of example 1.1, there's another example that's given, and that's or rather a practice problem that's given, and I want you to do this as practice in preparation for class. Is each change chemical or physical, and what kind of property is demonstrated in each case? You can use the top example as a guide to what's expected for these answers. Okay, good luck.